Hey YouTube, it's Brendan with Keysack Prep. Here's another video describing how to solve a particular trig identity. So the trig identity that we have here is sine of x minus sine of x times cosine squared of x is equal to sine cubed of x. Now, in order to solve this problem, we kind of run through a list of ideas of things that we're able to do with trig functions. So looking at this from the beginning, I don't really see any Pythagorean identities that I can use. I don't really see any way to FOIL it. I don't see any fractions. Everything's already in sine and cosine, so I can't really change it. But what I do see is I can factor out a sine of x from both of these terms on the left side. So sine of x and another term having a sine of x means I can factor out a sine of x from both terms. So I'm going to turn this into sine of x times 1 minus cosine squared of x, and that equals sine cubed of x. Now, this 1 minus cosine squared of x, you may know that there is the trig identity, sine squared of x plus cosine squared of x is equal to 1. And if I were to solve this for sine squared of x, I would find that sine squared of x is equal to 1 minus cosine squared of x. Well, that's awfully convenient, isn't it? Because here we have a 1 minus cosine squared of x, and here we have a 1 minus cosine squared of x. So what that means is I can replace that whole 1 minus cosine squared of x term with sine squared of x. And I know that sine of x times sine squared of x is just sine cubed of x, because you add the exponents. Like this would be sine of x to the first, sine of x squared. So adding those, I find that sine cubed of x is equal to sine cubed of x. And there you have it. Pretty straightforward trig identity to solve, as long as from the very beginning you notice that factoring is the way to go. Thanks so much for watching. Hope you enjoyed this video.